Graph the parabola from the given equation. We have the square of y plus 2 equals negative 4 times the quantity x minus 1. This is a very useful form for the equation of a parabola. When graphing a parabola, it's often referred to as the standard form for the equation of a parabola, which we haven't learned about yet. Our text uses what's often referred to as Vertex form for the equation of a parabola, which is shown below in bold, though our textbook does refer to this as the standard form for the equation of a parabola. Because our equation has the y part squared, we'll write the equation in this form on the right, or the form x equals a times the square of y minus k plus h to graph the parabola. To begin to solve for x, we want to undo the negative 4 on the right. To do this, we'll multiply both sides of the equation by negative 1/4. This gives us negative 1/4 times the square of y plus 2 equals negative 1/4 times negative 4, or negative 4 divided by 1 if we want, times the quantity x minus 1. Simplifying on the right, notice negative 1/4 times negative 4 simplifies to 1. Let's also reverse the order of the equation and write the equation as x minus 1 equals negative 1/4 times the square of y plus 2. And now we'll add 1 to both sides of the equation, giving us x equals negative 1/4 times the square of y plus 2 plus 1. Now that we have the equation in Vertex form, or what our text refers to as the standard form for the equation of a parabola, let's work on graphing the parabola. The first thing to notice here is, again, the y part is being squared, and therefore the parabola will have a horizontal axis of symmetry, which indicates the parabola will open left or right. And because a is equal to negative 1/4, we know the parabola will open to the left and resemble this shape. Notice the parabola does have a horizontal axis of symmetry. And now let's identify the vertex, which is the point h comma k. Because we have plus 1 on the end, h is positive 1. And because we have y plus 2 inside the parentheses, and we identify k in the form of y minus k, k is negative 2. Y plus 2 is equivalent to y minus negative 2. Let's plot the vertex. 1 comma negative 2. And again, we know the parabola opens to the left. Let's also sketch the axis of symmetry, which passes through the vertex. And now we're going to determine some additional points on the parabola. To do this, we'll create a table of values. Though we do want to be strategic about which x or y values we select in the table. Let's begin by selecting y equals 0. Notice when y is equal to 0, we end up getting the square of 2 here, and then multiplying by negative 1/4 does not give us a fraction. So again, we'll select y equals 0. Performing the substitution, we have x equals negative 1/4 times the square of 0 plus 2, or the square of 2, plus 1. X equals, again, negative 1/4 times 4 is negative 1. Negative 1 plus 1 is equal to 0. We know the parabola passes through the origin. Let's plot this point. And because we have the axis of symmetry, we know there's a corresponding point on the opposite side of the axis of symmetry, which would be the point 0 comma negative 4. Already we can make a nice accurate graph of the parabola, but let's determine one more point. Again, being strategic about which x or y value we select for the table to avoid fractions, let's select y equals 2 so that we have the square of 4 on the right side, which is 16, and then 16 times negative 1/4 is equal to negative 4, which will avoid having a fractional value for x. So again, we'll select y equals 2 and perform substitution. So when y is 2, we have x equals negative 1/4 times the square of 2 plus 2, or the square of 4, plus 1. We have x equals negative 1/4 times 16 plus 1, which is negative 4 plus 1, which is negative 3. the parabola also passes through the point -3, 2, which is this point here, which means there must be a mirror image of this point on the opposite side of the axis of symmetry, which would be 4 units below the axis of symmetry, which is here. And now we can make a nice accurate graph of the parabola. Let's check this using Desmos.com. We've already set this up. Notice the vertex is the point 1, -2, and the parabola does pass through 0, 0, as well as 0, -4, in addition to -3, 2, and -3, -6. The graph verifies our work is correct. I hope you found this helpful.